Thevenin's theorem, and how to Thevenize a complex circuit. First about the theorem. Thevenin's theorem is named after M.L. Thevenin. It's useful in simplifying the process of solving for the unknown values of voltage and current in a network, and can be represented by an equivalent series circuit with respect to any pair of terminals in a network.
Here is what you should know about Thevenin's theorem. It states there that it is possible to simplify any linear circuit with just a single voltage source and a series resistance connected to a load. So the qualification of linear is identical to that found in the superposition theorem, where all underlying equations must be linear, so it means it has no exponents or roots. So Thevenin's theorem, it can also be used in analyzing power systems.
There's two things to remember in the Thevenin theorem. First is the Thevenin voltage, the open circuit voltage across terminals A and B. This means finding the voltage that the network produces across the two terminals with an open circuit between A and B. Next is the Thevenin resistance, the open circuit resistance across terminals A and B, but with all sources killed or shorted. So, through this theorem, a complex circuit like this can look like this.
So today we're going to discuss about Thevenin's theorem. So in this lesson, we are asked to find the RTH or the Thevenin's resistance and the VTH or the Thevenin's voltage. So first let's discuss how to find the RTH or the Thevenin's resistance. So if we're going to deal with um, the Thevenin's resistance, we're going to replace the voltage, which is right here. We're going to place the voltage in a short circuit. So the diagram will be like this. It will become like this. As you can see, the circuit is replaced with a short circuit. So now, the circuit, the two resistors is connected in parallel circuit. So we can apply the parallel circuit rule, which is to find the equivalent resistance. So how we can find the equivalent resistance? So we apply the product over sum. So R1 or resistance 1 times resistance 2 over resistance 1 plus resistance 2 is equals to 10 times 2 is equals to 10 plus 2. So therefore we can conclude that the resistance or the Thevenin's resistance is 20 over 12 or 1.67 ohms. Next, we are asked to find the VTH or Thevenin's voltage. So here you have a formula. V is equals to V1 times R3 over R1 plus R3. So E is the voltage between A and B. So it is found here, over here. So this is we can consider this as our R3 because this is the voltage between A and B. So our V1 is 14 volts, our R1 is 2 ohms, and our R3 is found over here between A and B. So with the formula we can derive now the VTH. We can solve the VTH or Thevenin's voltage. So 14 times 10 over 2 plus 10. So 140 over 12 is equals to 11.67 volts. So that is our VTH. Lastly, we can convert this complex circuit into a Thevenin equivalent circuit. So this circuit is equivalent to this circuit. So this is the simplest form of this complex circuit.